Hello and welcome to your stats warm up. All right, so this is just kind of a look back at the four major problems that we covered in Unit 8, which again was all about confidence intervals. So, number one, a New York Times poll on women issues interviewed 1,025 women randomly selected from the United States, but not Alaska or Hawaii. The poll found that 47% of the women said that they do not get enough time for themselves. Construct and interpret a 90% confidence interval that estimate the proportion of women in the United States who do not feel they get enough time for themselves. All right. So this right here was our sample statistic. And we want to use that sample statistic to come up with a range for possible values for the population parameter. All right. So again, for these, we're going to go to our stat tests menu. All right, this is dealing with proportions because we're dealing with percentages. So this is going to be a one proportion Z interval. All right, so one prop Z int. Now to get this, we need to know X, which is the number of successes. We need to know N, which is our sample size. And we need to know our confidence level. So the problem gives us two of those directly. It tells us the confidence level is 90%. It tells us the sample size is 1,025. It does not give us the number of successes. We have to find that ourselves, but it's easy enough. We're just going to take the 47%. We're going to multiply it by the 1,025. All right, so 0.47. Whoops, 0.47 times 1,025 gives us 481.75, but we'll treat that as 482. So we're going to say there were 482 successes out of 1,025. So if we put that into our one prop Z int, 482 successes, 1,025 sample size, a confidence level of 90%. And that's going to give us an interval that ranges from 0.4446 to 0.49589. So in short, we're basically saying, okay, I'm 90% confident. The true percentage is between, I'm going to round these a little bit. We'll say 44.5% and 49.6%. All right, but again, we're coming up with a range based on the sample statistic, and that range is a function of the confidence level and the standard error, the standard deviation that we calculate from that distribution. All right, number two, you want to conduct a poll at your school to estimate with 95% confidence the proportion of students in your school who have outside jobs in the evenings and on weekends. You'd like the margin of error to be less than 5%. How large of a sample must you need to produce this interval? All right, so again, this is our formula. Margin of error equals Z star times PQ over N. Now, when they don't give you an estimate for P, we use the worst case scenario, which is that P is 0.5, because that's going to end up with the largest possible standard deviation. So it tells us the margin of error is 5%, so we're going to use 0.05 here. All right, it tells us we're using a confidence interval of 95%. So again, this is going to inform our Z star. And specifically, to figure it out, we're going to have to go to inverse norm. There's 5% left over, but that means 2.5% on each side. And then again, we are going to look at the worst case scenario. So 0.5 times 0.5 divided by n. Right. So inverse norm we can do on our calculator. We get 1.96 is what we're going to actually end up getting. Ignore the negative. We always use the positive. So 0.505 equals 1.96. And then we've got the square root of 0.5 times 0.5 over the square root of n. And then it's just a matter of going through and actually just solving and working through the algebra on this. So we can multiply both sides by square root of n. Get this right here, 1.96. Now the square root of 0.5 times 0.5 is just going to be 0.5 because you're squaring 0.5, but then you're taking the square root. And then we can divide both sides by 0.05. Do some of that work on the calculator. So 1.96 times 0.5, divide by 0.05. All right, so square root of n equals 19.6. And then we're going to have to square both sides. We get n equals 384.16. But with these sample size problems, we always round up. So our final answer would be 385 people. All right. Number 3 is asking us to do the same thing. It's just asking us to do it with a different formula, all right? Because this one's not dealing with percentages. It's telling us we're sampling from a population with a known standard deviation of 20, and we want to conduct a confidence interval that has a margin of error no more than 4, all right? So we're out of the proportion world, and we're into the quantitative world. So it's going to still be margin of error equals z star, but then we switch our formula, all right? We're no longer using the standard error for proportions. We're using the standard error, the standard deviation for means, but the rest of it works exactly the same, right? This 4 goes in for our margin of error. This informs our z star, and this is our population standard deviation. All right, so we end up with 4 equals, now, again, it's going to be the same exact inverse norm we just did. So I'm going to write it out, but I'm not going to type it into the calculator because we literally just did it. It's going to give us 1.96. And then we're going to have 20 over the square root of n. All right, so again, I'm going to do a couple of steps in one here. I'm going to multiply both sides by the square root of n. And I'm going to work this out to be 1.96 times 20. And then it's up to you. I'm fine with you just doing the rest of this sort of on the calculator and saying, okay, 1.96 times 20. Then I'm going to divide that by 4. And then I have to square both sides and ending up with your n that way. If you want to show more work, you're welcome to do that as well. But I'm fine with you just saying this. But you do have to recognize that we always round up. So our final answer would be 97 people. Okay. Now, last one here. About 130,000 high school students took the AP Stats exam in 2010. The free response section of the exam consisted of open-ended questions. Each free response is graded on a 0 to 4 scale. For one of the problems, a random sample of 30 papers had a mean of 1.267 and a standard deviation of 1.23. Construct a 99% confidence interval for the true mean of this question. So again, these are our sample statistics. All right, so sample statistics, and we're using those sample statistics to come up with a range for the true population mean. All right. Now, when we do this, all right, we're still going to go to the test menu. Make sure you do not pick Z interval. We never use Z interval. That's only when you know the population standard deviation, which we don't know. We know the sample standard deviation. So that means we're choosing T interval. All right, now when you choose T interval, it gives you the choice between data and stats. We obviously don't have any data in this problem, so we're going to choose stats. All right, stats needs to know X bar, which is your sample mean, and the problem tells us that it's 1.267. I can type that in. It needs to know the sample standard deviation, which the problem gives us as 1.230. So I can type that in as well. It needs to know the sample size, which the problem tells us is 30 student papers. So our N is 30. Change that. And it wants to know a confidence level, which in this case, we are saying we want to be 99% confident. So I can put in that 99%. I've got all my values in. I can hit calculate. And it's going to give me a range from 0.64801 to 1.886. So, given that this question was from a 0 to 4 scale, it seems like it was a pretty hard question because most people didn't even get 2 points on it. But we can say we are 99% confident. The true mean for this question is between, we'll just say 0.65 and 1.89. Right. So that's kind of the best interval we can come up with based on the results that we got from our sample. All right, so again, these are the main types of problems you're going to see. Creating intervals, which again, you're welcome to create the intervals using the calculator feature. You don't have to do them by hand. And then calculating sample sizes, this is where you kind of need to know the work and to know the formulas because your calculator won't do this for you. And then the only other thing I would remind you of on these is always round up when you're coming up with your final sample size. All right, so hopefully this was helpful. If you have any questions, let me know. Otherwise, have a great day. Bye.